Hello everyone. In mathematical methods, we are going to see about the result of h nu of b nu of f semicolon si equal to minus z square h nu of f, which means f is nothing but f of rho semicolon z. So this is the result we have to prove. Before that, we need to consider b nu of f. B nu of f is can be written as dou square f by dou rho square plus 1 by rho dou f by dou rho minus rho square nu square divided by rho square f. So what we do means multiply by row of minus nu minus 1 into row of plus nu plus 1. So if we multiply means what we get, if we multiply in each of the terms means we get the form of row nu plus 1 as it is in the first term, and it will become as row nu plus 1. So the row terms are getting cancelled and the left of the term is row nu. And here also if we do the multiplication means take row minus nu minus 1 as it is common in all the terms and simplify the rest of the terms. If we simplify means we get the form of row nu plus 1 dou square f by dou rho square plus, and here what will happen means row nu, which means here row minus nu minus 1 goes out and the left of the term is this one, and it will goes up means row minus 1, this plus and minus getting cancelled, and we get row nu only. Row nu dou f by dou rho minus here this term goes out and the left of the term is this one, and if we take to the upper side means, which means numerator means, we get minus 2, and nu plus 1 minus 2 will be nu minus 1 nu square f. So this is the form. So next step what we do means we have to add and subtract nu rho power nu dou f by dou rho in this terms. So if we add and subtract this means we get this form, and what we do means this term and this term having the common forms of rho nu dou f by dou rho. So if we take means if we simplify means we get the form of nu plus 1 into rho nu dou f by dou rho. So this term as it is and we combine this term, we get this form, this term as it is and this term also as it is given. So what we do means using the partial differentiation, this term as it is, and if we take dou by dou rho of rho nu plus 1 dou f by dou rho means, if we do the derivative means uv method means u as it is and v dash is dou square f by dou rho square plus, and this term as it is dou f by dou rho, which this term is rho plus 1 rho power uh, rho power nu plus 1 minus 1, this plus 1 minus 1 getting cancelled, and rho nu term as it is. So instead of this we can replace dou by dou rho as into rho nu plus 1 dou f by dou rho, and instead of this we can also replace dou by dou rho nu, take nu as common, dou by dou rho nu f. So if we do the derivative means rho nu dou f by dou rho minus f as it is, and rho into nu and nu getting square, so nu square rho into nu minus 1, this term as it is. So it is in the form of u v dash plus v u dash. So d by d into uv, this term. Okay, next what we do means, so take here dou by dou rho as common means we get the terms of rho into nu plus 1 dou f by dou rho minus nu into rho nu f, this term we will get, and add and subtract in each of the terms rho nu rho minus nu in here and here also, and take row 2 new plus 1 as common. So if we multiply row new row minus new in each of the term means we get this form. And next step we want to take 2 new plus 1 as common. Here there is no row, which means 2 row is having but not having a row value, so multiply and divided by row. Then what we get means row minus new minus 1 dou by dou row 2 new plus 1. So if we take this one, new added means row power 2 new plus 1. The left of the term is row minus new dou f by dou row. And here what we do, this 2 new in this term and this also, if we take means the rest of the terms of new into row minus new, this goes to a numerator means minus 1, so minus 1 of f. So next what will get, a row into minus new minus 1 dou by dou row 2 new plus 1. Here what we do means as it is uv form, so dou by dou row of row minus new f, which means if we differentiate this term u as v means we get this one. And plus u v dash means minus new row power minus new minus 1. Okay, so we can, instead of this we can replace this. Next what we do means we can split this 2 new as uh, 2 new as row new and row new. So take row in row power new plus 1 into row power new dou by dou row minus new f. Okay, if we split means we get this term. So now what we are finding means we are finding the b new of f value. So we have to take the Hankel transformation of this form. So Hankel transformation of b nu of f comma epsilon is nothing but h nu as it is. Instead of b nu of f we are finding this term. So instead of that substitute this term comma semicolon, here xi. So we already know the result that h nu of row minus nu minus 1 dou by dou row nu plus 1 f of row semicolon psi can be written as I of h nu plus 1 f row comma psi. Okay, instead of this we can replace this term, so psi into h nu plus 1. Here f of p is nothing but this term. So p row new dou by dou row minus new f comma psi. Okay, instead of that we can, instead of f of p we can replace this. So we also know the another result, that is h nu of row new minus 1 dou by dou row 1 minus new f of row comma psi equal to minus I h nu plus new minus 1 f row comma psi. So instead of that replace new as new plus 1 means we get new plus 1. Here also new plus 1 means minus 1 plus 1 getting cancelled, we get new dou by dou row. And 1 minus new uh, minus 1, this minus 1 and plus 1 getting cancelled, and row minus new. And f of row as it is epsilon, here minus epsilon. Instead of replace new plus 1 means plus 1 minus 1 getting cancelled, h new f of row comma epsilon. So instead of this term, the result we know this one. Instead of this we can replace new as new plus 1 means we get the form. So this two are same. So what we do means instead of this we can substitute this one. So epsilon into minus epsilon h nu of f of row comma psi. So if we multiply means minus epsilon, which means minus psi square h nu of f of row comma epsilon. So this is the result we have to prove. H nu of b nu of f comma psi equal to minus psi square h nu of f comma epsilon. This is the result we have to prove. We proved. Hope you all understand, and thank you.